So as the learning goal says today, we're still in lesson 7.2, but now you're going to be factoring 4-term polynomials, and you're going to do it by grouping. And what ends up happening is sometimes we have 4-term polynomials that do not, every term, you cannot get a GCF out of all 4 terms. You can't find a common factor that all of them have when you do not group them. But if we do it by grouping, which is what we're going to learn now, then we can actually see that it is factorable rather than saying that it is not. So when there is a 4-term polynomial, we are going to try factoring. We're going to try to factor by grouping. You must at least attempt it. You cannot just look at a 4-term polynomial and say it is not factorable. You try to do the GCF like we did yesterday with our binomials or trinomials. And here we have a 4-term and you say, I did it, there wasn't a GCF, I cannot factor this one. No, you have to try this factor by grouping to make sure. So here's what we'll do. We'll make 2 groups, factor by grouping. We'll divide the polynomial into 2 groups of 2 terms each. So we'll have 2 groups, there'll be 2 terms in each of those groups. So 2 times 2 is 4 to cover the 4 terms of the polynomial. Then we will GCF each group. So each group of 2 terms will have its own GCF. Because here's what ends up happening. We actually find out that if this is factorable by the GCF method, each group should have a common factor. They should have a factor that if we were making a list, we'd be able to circle them in both of them. We'd be able to say they have a common factor, and that ends up becoming the GCF of our 4-term polynomial. So we really are still using the GCF method to factor it. It's just, this is how we'll have to accomplish it. So here's an example for you. I have the polynomial 6x squared minus 4x cubed plus 12x minus 8. Notice what's the first thing I did other than make the 2 groups. I made 2 groups by putting parentheses around the first 2 terms, and then I put parentheses around the next 2 terms, but what else did I do in that step? Check it out on your papers. Check it out up there somewhere. Help me. What did I do besides inserting parentheses to make my 2 groups? I made it add the opposite. Yeah, those 2 subtractions I changed to add the opposite. Trust me, if you don't do this with this, I keep saying it's going to go bad, but it's really going to go bad, okay? So just change any subtraction to add the opposite while you're making your groups, okay? So do that first and then put your parentheses around. So notice I say the GCF of this first group is 2x cubed. So the part you're going to get out of today is how much work do you have to show getting that GCF? Did you have enough practice yesterday that you will be able to now look at 6x to the 4th and negative 4x cubed and say the largest constant factor I can divide out of both of them is 2. So if I look at 6 and I look at negative 4, I say, well, the biggest number that I can divide out of both of those is 2. I look at the x parts, the x to the 4th part and the x to the 3rd part, and I say, well, one of them's got 4 factors of x, the other has 3 factors of x. That means I should be able to divide out at least 3 factors of x out of both of them. Thus, my GCF for that group becomes 2x cubed. Then we do the actual dividing. We say, okay, 6 divided by 2 is 3. X to the 4th divided by x cubed is x. So this is the result after dividing that first term by the 2x cubed. This is the result after dividing the second term by that GCF. Negative 4 divided by 2 is negative 2. X cubed divided by x cubed, they cancel out. They're no longer there.
How do you get the 2x?
So again, I didn't show the word for getting that, but really here's what happens. We have I got to get rid of these arrows so I can see where there are negative signs. Okay. So what we really have here is we have negative 6x to the 4th, which can factor to 2 times 3 times x times x times x times x, right? We have that negative 4. Okay, this should not be negative, should it? That's 6. Okay. we have that negative 4x cubed, which can factor to negative 1 times 2 times 2 times x times x times x. So this is just like we did yesterday, but we're wondering if we can start doing it with mental math. They both can have a 2 divided out of them. They both can have 3 factors of x divided out of them. I am left with 3x. There's that. I am left with just a negative 1 times a 2. There's the negative 2. So factoring just a binomial, that first group is a binomial now. Its GCF is 2x cubed. And after we divide it out, the result is 3x plus negative 2. Follow that? Want to ask more questions? Okay, what's the GCF of the second group? 4. So in other words, look at that group and you say, okay, here's my group. What's the largest number that can be divided into 12 that can also be divided into negative 8? It isn't just 2, it's 4, isn't it? So we divide out a 4. The first term has an x, but the other term doesn't have an x, so we're not going to be able to divide an x out of both of them. So our GCF has to be the 4. And then, after I divide 12x by 4, I should get 3x. After I divide negative 8 by 4, I should get negative 2. So this is the second binomial now factored. It's its factored name. They each have their own factored name. And then notice what's true. They both have this common factor, 3x minus 2. 3x plus a negative 2, which is 3x minus 2. They have that factor in common. So it's kind of like I could write that over here like this. I have 2x cubed times 3x plus negative 2. And I have 4 times 3x plus negative 2. And I could say, oh, these guys have that in common. There's their GCF. There's their GCF. What's left after I divide that GCF out of both of them, I have a 2x cubed left. I have a 4 left. That's how I get the other factor. So today, here's what should always happen. Your factored name should be a binomial times another binomial. This, let's write this in our notes. This is the factored name right here. This is the factored name of that 4-term polynomial. 6x to the 4th minus 4x cubed plus 12x minus 8. That is its factored name. Okay, let's go practice. Let's do our own here. Let's get our work in. We have 6a cubed plus 8a squared plus 9a plus 12. Any subtraction to change? No. So now what I can do is I can just go right to making the groups. I'll take the first two and group them together. Bring this plus sign down, that's in between here, and make my other group 9a plus 12. Okay, now, off to the side, wherever you have to do it, whatever amount of work you have to show at this point, you need to GCF each group. So let's just take care of the first group. We have 6a cubed plus 8a squared. What would be the largest number that we could divide out of both 6 and 8? 2. So we're going to have, I just said number. Did you hear me? I just said number part. 2. And now I'm going to look at the variable parts. They both have variable parts. We have one that has an a cubed, the other one has an a squared. What's the most I can divide out of both? A to the second, yeah. The first one has 3 factors of x, but the second one only has 2, so I can only take 2 out of both then. So now, in my parentheses, I will have the result after I would actually divide those by that. So what is 6a cubed divided by 2a squared? What is 6a cubed divided by 2a squared?
3a plus 4.
3a plus 4. In other words, 6 divided by 2 is 3. A cubed divided by a squared is a. So I have 3a plus 8 divided by 2 is 4. A squared divided by a squared, they're gone. I just have 3a plus 4. Bring down the plus sign between the groups. Now we GCF the second group. 9a plus 12. What's the largest number that can divide out of both 9 and 12? 3. Do they both have a's? No, so we can't divide out a variable part, can we? So we say that's as good as our GCF is going to get, 3. 9a divided by 3 is 3a. Plus 12 divided by 3, 4. If you did a good job, if it's factorable by grouping, right now you should say, oh, the 2 parenthesis ones should match. Do they? No. We have a 3a plus 4 in both of them. That has now become the GCF of the whole 4-term polynomial. We have factored it so that we can see what the GCF of the whole 4-term polynomial is. It is 3a plus 4. This is typically where it gets confusing for students. They want to bring down that plus sign again. But we don't bring down the plus sign because remember when we did the GCF yesterday, we had a monomial GCF. We put it out front and then it got multiplied times our binomial or our trinomial other factor. So this is multiplication now. After I divide this first group factored name by 3a plus 4, what do I have left?
2a.
I have the 2a to the second. Now I bring down the plus sign because I have to deal with this other polynomial, this other group. After I divide a 3a out of this group, what do I have left? 3. This is the name, factored name. I take out that GCF, the only thing left is the 3. This is its factored form. This is its factored name. But we are going to do a check problem. So you decide. We have a binomial times a binomial. We have a couple of different methods at least for multiplying these. You can use FOIL. You can use the rectangle method. But I want you to multiply it back out. So the factored name should take us back to our 4-term polynomial. And you don't go looking through the 4-term polynomial was to know what your product should be. You actually multiply it out and see what products you get. We know that after we FOIL, we look for like terms. Do we have any? Or after we do the rectangle, we look for a diagonal or some like terms. Do we have any? No. So we write down, what do we have then? We have 6a cubed plus 9a plus 8a squared plus 12. Then we go check out, what was it that we were actually factoring in the very beginning? Well, I see that I have a cubed, a squared, a, and a constant. So right away I see that that's in standard form. So I'm going to rearrange mine to standard form so I can make a good comparison. Hopefully putting a polynomial in the standard form by now is almost mindless. Does it match? Do we have a polynomial that we renamed in factored form? Again, it's important that we understand that that name that we just got, that binomial times polynomial, is just another name for this polynomial. It checks out. Questions? Let's go to the back side. There's mine. Okay. As you know, as you're writing this next step, I see this one has subtraction. So I think it's going to be in my best interest to change that subtraction to add the opposite. After I have done that, I can make my groups. So, first bullet point, make your groups. Second bullet point, GCF each group. Okay, you go ahead, you do this one. You GCF each group. Do this step without me, and let's see if you get the same thing. Show whatever kind of work you got to show to make it happen, so that you can be successful. Or show as little work as you need to, but be successful. When you're done, will you look and see if you do the same thing I did? Anybody use, so the GCF for the first group, did you decide 2x squared was a good GCF? Okay. Then after you divide that out, you get the same result I do, x plus negative 3. Okay. Well, the second group, do you agree with my GCF in the second group? Did you GCF of 3? Yeah. Benton did. What did you GCF it with, Benton?
Negative 3.
Okay, why'd you do negative 3, Benton?
Because otherwise the two equations wouldn't match. Because on the right it says negative x, and on the left it says x. And vice versa with 3.
So I'm just going to correct one thing about what he said. There are not really any equations going in because of equal signs. But the binomial factors that we end up with for both of them are not matching, are they? At this point, these fellas got to match. Here it's a positive x, like Benton said. It's a negative x in that one. This one has a negative 3. That one has a positive 3. So here's what you do when that happens. When they just are reverse signs of what they need to be, you make your GCF negative. So instead of a positive 3 GCF, we're going to have a negative 3 GCF. Now, that'll make this a negative 3, and this will become a positive x. And these two turned around will be what we need them to be. So sometimes you have to be, a critical thinker that says, well, oh, if I did this, this would create what I needed to create. Now we have a GCF for each group. We can say that x plus a negative 3 is the GCF. They both have that. No plus sign here. Times the other binomial factor that I should get. Well, if I take this group, factor name and take that x minus 3 and divide it out of there, what do I have left? 2x to the second. This is where the plus sign comes down. And now when I take this group and I divide out that x plus negative 3, what do I have left? Negative 3. And now we'll clean this up. X minus 3 times 2x squared minus 3. Okay, multiply it out. Make sure we got a good answer. Check it out. We're going to do check problems today. We're not going to be just happy to have answers. You don't have that many problems to do. Any like terms?
No.
No, probably won't happen. Was this one in standard form to start with?
No.
No. Had the cube, the squared, oh, the 9 and the 3x were out of place. Okay, so I'm going to have those guys trade places in my answer here. I guess I can do some cleaning up while I'm at it. I got mine to come out to our original 4-term polynomial. How about you? I guess we did well then. Okay. One more. And in our notes, we won't check this one because I want you to be able to get to work on your homework, but here's what you guys are gonna do. I already know. I'm just like I'm a fortune teller. You're gonna go like this. Y cubed minus 2y minus 8 plus 4y squared. You're gonna stick your parentheses in and be ready to just dive in and say, you know what, it can be subtraction instead of addition, who cares? And if you want to go ahead and do that, you can see if you get the same answer we do, those of us who are not going to do that. Because I'm pretty sure we wouldn't. Okay, so I want you instead to do what? Before you stick those parentheses in, you're going to write it as add the opposite. And now when you stick the parentheses in, it's going to go better, just trust me. Okay, we'll do this one together just to get through it hopefully quickly. What do you think is the GCF of the first group? Just y. The first term doesn't have a constant other than 1. And the first term has 3 factors of y, but the second factor only has 1, so y is the GCF of that first group. So we have y, what here? Y squared. Yeah, y cubed divided by y. Take that y out of there is y squared. Negative 2y, divide out that y is? Negative 2. Plus, our groups are working independent of each other right now. They're not on the same page at the moment. Okay, so now what's the GCF of the second group? 4. Okay. What's negative 8 divided by 4? Negative 2. 4y squared divided by 4? Y squared. Do we like it?
Yes.
Because why?
Switch.
Because if we switch this around, we'd have y squared plus a negative 2. And what is it that we're looking for? What do we want to happen? What, Eddie? They're the same. The parentheses, I'm gonna assume that's what you mean. The parenthesis parts are the same, right? So now we can say that is our GCF of our whole thing. And the other factor, multiplication, no addition here. The other factor is what then? Y plus 4. Clean this up. Y squared minus 2. Y plus